Hello everyone and welcome. In this video we're talking about how Audi is eliminating body roll in their SQ7 through the use of two electronic sway bars, one in the front and one in the rear. And an electronic sway bar or anti-roll bar acts just like a traditional anti-roll bar, with the difference being you can vary the stiffness of that roll bar through electronic control, which is very cool, and there are unique advantages to doing that. So we're going to get into that in this video. And there are other companies which have done electronic sway bars. This isn't actually anything all that innovative, but what's different about the Audi system is that they're now incorporating it into a 48-volt system, so it's a bit more powerful. It means you've got a bit more range of control, which is pretty cool to have. So how does this work? Well, let's say you're going around a corner and your center of gravity is up here, it's leaning over to the left, so the body of the car wants to lean left as you're going around that corner. Well, that means the body of the car is going to want to come closer, it's going to be compressing down on this side of the suspension, and then it's going to be stretching out this side of the suspension. So your anti-roll bar is going to want to counter that. So you've got an electric motor which is going to provide a torque through a gear reduction, so a 200 to 1 gear ratio that's going to be used there, about 200 to 1, pretty insane. So a huge amount of torque multiplication. With this 48 volt system, a 1.5 kilowatt motor, they're saying that they can have 1200 newton meters of torque going through this, or about 900 pound-feet. Pretty incredible, which you're going to need a lot, obviously, for a big, heavy SUV as it's going around a corner. So you're going around, it's compressing down, and because these two are coming closer, you want to push this wheel away from the body. So the body's trying to compress in, and then the anti-roll bar is going to be twisting. That electric motor is going to try to rotate this downward. It's connected to the control arms, so the control arms freely pivot, but then the anti-roll bar is connected to both, so it connects those two sides. So it's going to try and press down that side, which is going to push it away from the body, or the other way you could think of it is pull up the other side. So the other side of the body is trying to get away, and it's trying to push that wheel up towards the body so it flattens the vehicle out, and the vehicle remains flat through that corner. So very simply, the car turns, the body rolls, and then the motor provides a counter torque to prevent that body from rolling. So it's looking at the steering angle from the driver's input as well as the vehicle speed. It's not using an accelerometer, because using an accelerometer would then be reacting too late basically to the g-forces that the car is feeling, and then the roll would have already occurred. So it's looking at the steering input and your vehicle speed, and then predicting how much torque does it need to provide in order to keep that car flat as you go through the corner. Now, probably the coolest thing about this system is that you can change the understeer and oversteer characteristics of the car in real time. So whether the front starts to lose traction or the rear starts to lose traction, you can make real-time adjustments to keep the balance of the car very neutral. And so how does this work? Well, if you think about a car, let's say this is the front of our car here, and it's going around a corner, the amount of load transfer to these outside wheels here is dependent on its center of gravity and its track width. You can't really change how much load transfer you're going to have there, but you can change which tire, front to rear, gets the majority of that load transfer, and partially that's based on how stiff are your anti-roll bars. So for example, if you had a front anti-roll bar which was infinitely stiff, and then you had a free pivoting rear axle, so it's just simply can rotate about that rear point, as you can imagine, as you go around a corner, all of that load's going to be transferring to that front left tire because it's rigid. So the car wants to lean, but it can't lean even though the rear pivots because the front is completely rigid. So you're going to have a lot of load transfer to that front left tire, and as a result, because you're not evenly distributing it between the front and the rear, and you're sending so much load transfer to that front left tire, it's going to start to understeer because this tire is going to be overloaded. So the front of the car is going to start pushing forward, it's going to start to lose grip. Well, if you do the opposite, if you have a super stiff rear axle, or rear anti-roll bar, then of course you're going to overload that rear, and the rear is going to want to slide out on you because it's got too much load transfer going to it. So in real time, based on the fact that you can change the roll stiffness of these axles, the front and the rear, you can change that rear roll bar stiffness or the front roll bar stiffness. You can adjust the balance of the vehicle as it's going around a corner. So you can make it want to oversteer, you can make it want to understeer, or ideally you can keep it very neutrally handling so it goes around that corner and it doesn't get squirmy, it doesn't, become unpredictable. It does what you want it to do, and it allows you to go around that, with the maximum speed possible. So the very basics of it, if you have a very stiff front anti-roll bar, then you're going to experience understeer. If you have a very stiff rear anti-roll bar, then you're going to experience oversteer, and you can make adjustments between each in order to have the ideal handling vehicle from a dynamic standpoint, how it behaves going around that corner. So thank you all for watching, and if you have any questions or comments, feel free to leave them below.